Hi, my name is Bill Fortney, and thank you for being here for this last video in the series on probability and statistics. What I'm going to do here is step through an example to help you see how all of the other pieces come together. I'm assuming that you have the basic foundation from the first videos on variability, what we do when we're taking data, from the design of experiments videos that teaches you about how you design the experiment, and then the three tools for understanding is data set A different from data set B. And then here I'm just going to go through and show how do you analyze and get the information out. Okay, so let's just start with a review. Why are we even doing this? And if you remember, as engineers, we need reliable data to make good decisions. And design of experiments is the foundation of how we ensure that when we go to collect information from the real world and we use it in order to draw conclusions, that when we're questioned, we're able to explain how we know. We're able to be certain about what we know and about what we don't know, and to be able to have proof for it. And that's really what it's all about, so that we have reliable information for good decisions. Okay, and you remember what it's going to look like. We're going to have some engineering question, something we need from something in the real world. We're going to design our experiment and collect data. We'll check it for validity. Then we're going to be detectives. We're going to explore the data and learn about relationships to gain insight for our decision. We're not just looking for one answer. And there's three basic questions we're going to be asking that data. What can I expect of you? Does variable A impact our thing of interest? Is data set A the same as data set B? And then if A does impact B, if there is a relationship, what is that relationship? Okay. And this second question is the bread and butter for design of experiments. And really most of what we do as engineers is this second question we're always having to explore. Okay, and then we saw how this fit in with the model that you're using in lab. You have your DOE guide and summary for designing it. Then you check and you do your analysis. So here's what we were worried about. And this was back when we very first got our 3D printer. So 3D printing was very early technology. And what we were wondering is, what is the strength of a 3D printed part? What's the modulus of elasticity? So if we wanted to analyze to decide how large something needs to be to hold a load, what's the modulus? And so we were curious about how that modulus changes by the fill rate. We were also curious about whether it changed in terms of what direction the load was applied. So if the load was applied up, or if the load was applied sideways. So we decided to create a design of an experiment to be able to test this, to get an idea of what the modulus was from our printer. So what did we do? Well, we remembered at the end of all of this, we were going to have to answer these three questions. Was the process stable? Was the 3D printing, the whole measurement process, stable? Do our samples appropriately represent the real thing we're trying to, the population? Do our measurements estimate the true values? And then we remembered that variation is in everything, so we took multiple readings. That what we're measuring may be changing, so we carefully designed our experiment, and that our measurements are only an estimate. So we considered all that. We followed this process. We went through the steps just like you're doing for your DOE, and we designed an experiment to answer our question. And here's basically what we came up with. We said, okay, let's print beams. We'll do a 30% and 100%, and let's use the beam equation. We have a cantilever beam, and we're going to come out here and we're going to put a weight on it, some distance away from the cantilever point and some distance away from the end of the beam. We then will measure the deflection, and then we can rearrange the beam equation in order to calculate E. So that was the basic idea of what we were going to do with our experiment. So we decided we would have two fill rates, 30 and 100. We would have two orientations. We would check it in the up direction and the side direction. And we would use three masks, small, medium, and large, that we were going to hang on there. So that was the basics of our experiments. We'd have a total of 48 tests. And the way we went about doing it is we supported the beam on a table, and we had a machinist scale that had 64ths divisions, And we would look at the start position, we would hang the weight, look at the end position. From that, we could calculate deflection. Now, I know that might seem crude, but you have to remember this was at the very beginning. We didn't have the milling machine. We had just gotten a 3D printer. We didn't have dial indicators. All the things that are very common in the lab now. If I was doing this experiment again, I would put a dial indicator on it, I would deflect it, and I would measure in thousandths or 10,000ths. We didn't have that technology at the time, so this is how we did it. And you can look at the DOE summary sheet, see the details of the experiment. I'm not going to go through that in this. I want to focus on the data analysis. But one thing I do want to say is all of these variables were fixed. We measured them one time and they didn't change. It was the start and the end point that were measured every time we hung the weight. So with these, what we did is we measured them initially. So remember, there's variation and everything. So we had marks and stuff. We measured the length multiple times and we averaged it. That's our length. We measured this multiple times, averaged it. That's our length. Same thing with A and B on the beam. We measured it 3 times in 3 different places on the beam and averaged those. Again, what am I doing? I'm applying what we've learned, that there's variation in everything. But once we measured these, you'll see in our data collection sheet, these are constant for each beam. And we printed 2 beams. We printed one of these and one of these, and they were used for all of the experiments. And again, you'll see those consistent measurements in the data sheet. Okay, so we printed 1 beam and we were going to test each beam 4 times. So this is what our experiment looked like in terms of the matrix you're used to seeing now. Factor 1 fill, we had 30 and 100. Factor 2 mass, small, medium, and large. So that was going to be repeated for each 30 and 100. And then orientation, side and up, those would be repeated for 30 and 100, small, medium, and large for each one. So we had a total of 48 tests, our 12 treatments times the 48 tests, and we were going to run this completely randomized. So how did we go about doing that? Well, we took all of our treatments and we wrote them down here. So the small, medium, and large, we wrote those down 4 times each. We did the same thing for all these others. We then put a random number in here. In Excel, we just put the random number function. We sorted it by random number, and then we added the run order right here. And so that's what that looks like. So that's how we set things up. And you can look at, like I said, you can look at the DOE summary just like you're creating to get more details on how we actually did the experiment. But I want to focus on the data collection here. Okay, so we designed the experiment. The next thing to do is we took all the data. And so here it is. One thing I want to point out. First thing you want to do is take your data, right-click on that tab and say copy, and make a copy of it. I call mine data working. Everything I do is in data working. That way, if I do something to data, if I mess something up, I can always go back to the original, and I always have it. So just a pro tip from not doing that times, make a copy and don't ever touch this data original. Leave that there. Okay, so we've collected all our data. And so what's next? Well, the next step is to ensure the data is valid. So how are we going to do that? We're going to plot it in run order. Then we're going to sort it by all of our independent variables. Okay, so your bread and butter to do the analysis for your design of experiment initially to explore is a pivot table. And again, one suggestion, you know how to do a pivot table. I'm going to go into data working. I'm going to highlight everything, do a new tab. Here's my pivot table. Okay, once you do this pivot table, you may want to create other ones for the different variables that you're going to be looking at. If you do that, don't come in here, right click and say copy. Go back and create a new one. I one time was doing a pretty big analysis and I had copied my pivot tables a bunch of times. And what I found is I would change one pivot table and another pivot table would change. It was like somehow they were linked. I don't know if it's an anomaly or what, but since then, I don't do that. Okay, so we need to look at what we measured. What did we measure? We measured start point an endpoint. If you recall, I'm going to go back to our diagram here. We don't need to check each of these because we didn't measure them every time. We only measured these two every time. And so that's what we're going to be measuring. So let me go back to my pivot table. And so now I'm going to come down and I'm going to pull down my start point. And I want the average. So I'm going to change that to average real quick. And the first thing I want to do is I want to see it in run order. So I'm going to pull my run order down, and there it is. And what am I looking for? I'm looking for anything that doesn't look random. And I look down through here, I don't see anything. I don't see like all the data's here and bammo, it's all up here. I don't see a trend of everything going up. Nothing strange there. And so then what I'm going to do is I'm going to sort it by all of my independent variables. So what did I have? I had fill, so I'm going to pull fill down. I had orientation, and then I had mass. Perfect. So you see I have fill, orientation, and mass. And again, what am I looking for? Hang on, and I'll show you in just a second. Again, if you don't know, one thing I want to show you is we're going to use boxes to help our eyes look on these. How do you do those? You click on the graph. That's critical. Click on the graph first. Say insert, go to your shapes, and just get a box, and just put a box on there. And then just go to shape fill and no fill. And so now you can put this box around points on your graph. Okay, one reminder, if you click on your box, sometimes they're hard to click. There we go. And then hold the control key down. You can copy it, and that way you don't have to create a new one every time. Okay, I'm going to delete that guy. Now, notice we have 30 and 100, and then side, and then large, medium, and small. I also could have done a different order. I could have done mass and orientation and done them this direction. It doesn't matter, and I'm going to show you why. Now, one of the things that I like to do, when I have 3 variables, I like to, when I'm looking at this, it doesn't matter whether they're all on the same graph or not. I like to put them on 2 different graphs. So what I'm going to do is I'm going to take fill, and I'm going to put it over here. Don't worry about it looking so weird. That's because they're both on there. I'm going to show you later how to get rid of that. But now I'm going to change this to just the 30. So that way I can look more closely right at the 30. And in fact, if you notice, let me pull fill back down. When I'm looking at this, notice how I have more points than everything. I can't see everything. You open it up and you're able to see all your points on there. Oh, wait a minute. Sorry. It's still just, let me put the 100 on there. Now you get the idea. There's too many. So you see, just make your pivot table longer. Then you can see all your points. But I like to do this and just look at one of them at a time. It allows me to focus in on it. Okay, so I want to go back to the PowerPoint for a second now to show you what you're really looking at when you do this. Okay, so here I have just my 30. And I have large, medium, and small. And here's what you're looking at. Look at this box right here. This is side small. It's those 4 points. This box, medium up, it's those 4 points. What you're doing is, when you're making sure your data is valid, you're looking at these repeat measurements. You're looking inside each of these boxes to see if there's anything non-random. And the order doesn't matter. Remember I showed you you could do side, or you could pull large, medium, and small, the mass up here. It doesn't make any difference because notice, look right here, this is side small. Look right here, here's side small. Look, it's the same information. It's just rearranged differently, just like right here. Look at this guy, see? Up, medium, it's the same information. Okay, so now those are sort of mechanics. Let's really look. So we looked at this, we didn't see anything. Let's look at 30. So I'm looking inside of each of these, and I'm like, that 0.44, it's just a little odd, and the same with 22. You know, these are pretty consistent. I don't know that it's a problem, but I'm going to keep an eye on it, okay? Especially for the starting point of 44 being so high. So now let me go down and look at 100. I look inside of here. I don't see anything that's not random. Okay, so another pro tip, what I do is when I'm going through this in Excel, I have a Word document opened. And so when I do a graph, I'll take that graph, paste it special as a picture in PowerPoint, and then I will write my notes about it as I'm going along. So these notes that you see right here, I would have had in PowerPoint. Okay, so now I wonder, here we go, 0.44. Did 0.43 yield it? And so it was larger than that all the time. Remember, you're not trying to get an answer. You're trying to be curious. You're trying to understand. I'm curious about that. So here's what I'm going to do. I'm going to come back to this guy. And let's see, which one was that? Was that 30 or 100? Okay, yeah, that was the 30. That was 0.44. So I'm going to go to this guy, and I'm going to go to 30. And then I'm going to get rid of these and just go back to run order. And look, okay, there was 43, there was 44. Oh, no, look, 45 and 48, it's back down. So if 43 had yielded it and it was permanently bent, then these wouldn't be back down. So no, I don't really see signs of that. So I'm not sure what. I'm just going to keep an eye on 44 and 42. I'm not saying something's wrong. I'm just going to keep an eye. Okay. So let's go to the endpoint. Same thing. So I created a new pivot table. I used this to do all my graphs, and I've got them as pictures right here. So you want to save a graph, you copy it, you come over here, and you paste it as a picture. That's what I like to do. That's how I save the graphs as I'm changing the pivot table. So I look down here. Everything looks okay. I'm looking inside of each one of these. I don't see anything that really looks strange. I'm going to look in 100, and I'm like, that's a little odd because these are all really pretty consistent, and that one's up. Same thing. So I'm going to keep an eye on 44, 42, and 35, okay? So I don't see anything with 100. With the endpoint. Anything that makes me think there's anything non-random. Okay, and then what I'm going to do is I'm going to go look at deflection. I know we didn't measure deflection, but we use start and end to create deflection. And so I'm just curious. I just want to go through and look at it. So I don't see anything in run order. I'm looking at 30. Don't see anything weird. There's my 0.44 and my 22. Those, I don't see anything strange that make me say what I saw on that start point was anything weird. And now here we go on, oh wow, look at 100. I drew the box. I just copied the box small, and look, that 0.35 that I said, it's not even in the box. Now, I need to go explore that. That's not random. So I go and look at it. I can't find anything recorded, nothing in the books. Nobody knows what happens. It looks like somebody got the weight wrong and they used the medium weight instead of the large weight, but I can't know that. And so especially since I've only got 4 points, that would make a pretty big difference. I am pretty comfortable that that was operator error. That was not something that happens, that's going to happen again, that I have to worry about. If I throw it out, that's really there. I'm pretty sure that's operator error. So I am going to throw out that 0.35. So what I did was I went to my working and I changed it and deleted that 0.35 and I renamed it. Now for me, for doing this with you so that you would see it, I renamed it data without 35. So if this has 0.35 deleted, all the analysis from now on is going to be without that 0.35. Okay, So now if we roll back, where are we? We've just checked our data. There's no signs that it's not random. It's valid. We're ready to move on to step 3. So what are we going to do? We're going to look at it visually. We're going to use our engineering knowledge to predict relationships, to see if we need to calculate anything else, like maybe look at difference, look at absolute or percents. Once we know repeat measurements are random, which we do, we can average it when we want to. Once we know an independent variable doesn't impact, we can average across that. In doing that, we're going to be looking, is data A the same as data B? And we have the 3 tools. We can look at the graph, we can look at confidence intervals on the average, and we can use our t-test. And then finally, we'll draw the engineering conclusions. Okay, so how are we going to approach this now that we're actually analyzing it? You remember our basic strategy. We're going to design the experiment so the only difference in the groups of data is the thing that you changed. Now, I recommend you going back to this table and just asking yourself, okay, this data set here, what's different between this and this? Well, it's the same beam. It was the same people hanging weights. The only difference is the weight. Okay, now how about this data set from this data set? Well, one was 30%, one was 100%. Our printers can only print one fill at a time, so one was one batch, one was another batch. One was one color, one was another color. Whoa, there's several differences there. So in my experiment, I have an answer for those. I had previous information that told me those things didn't matter. But you see, you need to go and look at this and carefully ask yourself, okay, when I start to go and look at groups of data, what's really the difference here, and review that. Okay, then you're going to look within and confirm that that's only random, You're going to then look between and say are the same or different, and we have those 3 tools. Okay, and remember what you're doing when you do that. Let's say this is 30 and 100. If we find out that fill has no impact, well, what that means is we can average all of the data for 30 and 100 fill together. If we find out that fill does impact, then we have to keep them separate. We have to analyze everything else for 30% and for 100%. That's what this question number 2, when we're asking it, means when we combine or don't combine. Okay, and then the last thing we're going to do is regroup the data in all the different ways to explore and learn. All right, so now for us, how are we going to do it with our data? We're going to use the pivot table and a line graph. The first thing, you're going to look at the big picture. You're going to look at the graph grouped by all 3 variables in run order. And you're going to use your engineering knowledge to see what you think it's saying and change the channel. And just some examples of how changing the channel can help. So here's all of the data set up one way. And you can see I have side and up boxed here. And you know what? It kind of looks like there's a difference. Over here, I didn't even box it because it's not. Down here, I changed the channel and put side and up here. And notice that it seems to be going up at every low, medium, and small for 30, but for 100, I don't see that as much. That's interesting. I could change the channel another way and put boxes right here. That starts to say, yeah, it looks like fill definitely made a difference. I could change the channel again. Again, look, at every change in side to up, whether it's large, medium, or small, yeah, I definitely think fill made a difference. We can see that pretty clearly. But again, I'm just wanting to show you how changing the channel, and on the pivot table, it's very easy by just changing the order of the variables that you have. Okay, you're going to want to look for a variable with obvious impact and separate it. So like for us, it's fill. If I look at fill with the channel change those ways, and there's one more way, and I'll show you how to do this, but especially with this graph, it's obvious that fill made a difference. At side and up, at all the different large, medium, and smalls, I mean, it's bigger all the time except 2 times when they just come together. So fill definitely made a difference. And so I could create this graph so I could combine. Remember what I'm doing? I'm combining all these and I'm combining all these, and there's no overlap there at all. Now, sometimes you will assume a variable doesn't impact and combine data, just like I did here, to show, okay, yeah, fill really did impact. We need to look at this data separately. And to do that, remember what I did is I assumed that side and up, large, medium, and small did not impact, and I could average across all those. Sometimes you'll assume that, and as you continue, you may find one of those does matter, and you have to go back and separate data out, and that's normal. We may find that 100% side and up mattered, so we can't just have one average. We have to have 100 side and 100 up. That's okay though, it's normal. Remember, you're then going to go and explore each of the other 2 levels at each fill level to see whether they matter or they don't matter. You can combine them or whether you have to keep them separate. And again, remember you're exploring, you're being a detective, not coming up with an answer. Follow the data to where it leads you. And then last tip, use the pivot table in the graph to learn from, but then go back and create nice looking graphs to tell the story you want to tell when you're actually presenting your information. Okay, so let's go through and let's look at 30. So I'm going to pull up and I'm going to go here. And what I want to show you on this one is, you remember I had 30 and 100. I'm going to click on this so I get my pivot table. And I said sometimes it's nice to have them both printed. So what I could do is I could take fill up here to my legend. And it's like, whoa, what happened? Well, here's what happened. The run order is our last one. And the 30 and the 100 didn't have the same run numbers because it was 1 through 48. So what I can do is I can go back to my data and there we go. And I can sort it in the same way I have it sorted in my pivot table. So fill, orientation, mass, and I create another column and I do run order 1 through 24 and then 1 through 24 again. Now I go back to my pivot table and instead of run order down here, I'm going to use that new guy. And lo and behold, bam, there I can see it. Sometimes this is a very handy way to change the channel. Now, I could have done the same thing by having it over here on filters. Here's why I don't like to do that. Because I come up here now and I only want to look at 30. Which one am I looking at? I have no idea. The filter doesn't tell me that. But if I put it over here on the legend, notice I see 30 right here. If I change that to 100, now I know that I'm 100, okay? So that's how I went through and did all of these tables, okay? So now let me jump to where I actually did this for the 30. So we already know we're gonna look at 30 and 100 separately. So the first thing I did was look at the orientation and the mass, the 2 different ways that I could group it. So I've got orientation down here and then I have mass down here. And I'm just looking to see, do I see a difference between side and up? Do I see a difference between large, medium, and small? And both ways can show me different things. When I look at this, when I go from side to up, it does look like there's a difference there. When I look at large, medium, and small, it really doesn't look like it makes a difference. Like when I look large, medium, and small. So the first thing I'm going to do is explore this. So I'm going to assume side and up doesn't matter. I'm going to average across those. So if you think about it right here, see side and up, I'm going to average all those for large, all those for medium, all those for up. First I'm not going to average them. I'm going to just combine them together so I can see this. So there's all my large, there's all my medium, there's all my small, with the side and up just thrown in there. It doesn't look like there's anything there. Just in case, I'm going to do the averages. And so there's my averages, large, medium, and small. And there's lots of overlap there. Just to be sure, I also went ahead and looked at it for side and up. Same kind of thing. There's lots of overlap. Okay, so how did I do these graphs? Let me show you. That's, again, where the pivot table can be such a huge help. I'm going to come up here to my pivot table, and I'm going to pull average of E down 3 times. So I'm going to change that to standard deviation. There we go. I'm going to change this one to count. There we go. And so now that's what I need to do my graphs. And I don't need run order. And so I'm on my 30. Let me move this guy so you can see what I have now. So you see there's my average, standard deviation, and my count. So what did I create for the graph? So come down here and look. And I want large, medium, and small for the side, large, medium, and small for the up. So I come up here, and there's large, and medium, and small, large, and medium, and small. So now what I'm going to do is I have a sheet where I graph my averages. And it's, whoops, I didn't mean to change that. It's right here. So notice I have a spot where I bring in the average, the standard deviation, the count, and then it calculates the error bars and puts it on 2 or 3. So all I have to do is insert some lines right here. And now go back to my pivot table. And okay, so I'm going to go right here. There's, oops, I didn't mean to get that 12. All I want to do is get this guy right here, large, medium, and small. Say copy, graph my averages. I'm going to come right here and say paste, paste special values. So there's those. And then I go back to my pivot table and let me grab these. And I just have to remember the first one is side, the second one is up, graph averages. I'm going to skip a line, values. And now I have to take this guy and make him the very bottom one. And then delete all those. Perfect. Now all I got to do is recopy my formulas for the others. And bammo, there's my graph. And I've got the, I'd have to reset this guy. I had it. There we go. And I can change the scale and everything. Okay, so you get that? So that's just a tip how you do the pivot table. So let's go back. So what did we find? We found that large, medium, and small definitely does not impact. We can combine over large, medium, and small. So let's do that and then look at side and up. So here's side and here's up. I did the confidence interval. There's no overlap. I also did 3 standard deviation confidence interval. There's no overlap. And just for overkill, I did the t-test. And so the t-stat was 3.4, 2.8 critical. There is a 0.29% chance that this difference happened and orientation doesn't matter. So I'm sure orientation matters. And again, how did I do the t-test? Let me show you with the pivot table. So I'm going to click on here, close that guy. So we don't need mass, we just need orientation. For the t-test, I need my individual points. So I'm going to bring run order back down, and lo and behold, there's my individual points. So now I just go in, just like I showed you on the video, I go to a T, and it asks me for my first variable, and I come right in here and I highlight these. It asks me for my second, I come right in here and I highlight these. Okay, you get it? See, that's where the pivot table can do so much of this work for you, especially when you have a lot of variables. Okay, so what did we just learn? We learned that for 30%, it doesn't matter. And let me see. Yeah, okay, that's what I thought. Let me pull it back in. So here's what we learned. We learned that the mass, statistically, there's not enough evidence to say that it matters. It's a little odd that they went down. I skipped over that when we were looking. Let me go back and look at the mass. Sorry about this. See how they go down? That's a little odd, but there's not enough evidence to say that mass matters, okay? For 30%, orientation does matter. We got to keep them separate. So what does that say? That says we can average across mass, large, medium, and small, but we have to keep all these sides and all these ups separate. That's what we said. So mass doesn't matter. That means we can average across all of these. That makes sense? That's what it means when we said they matter or they don't matter. So that's what we've learned so far. So now let's go look at 100 real quick. So we're going to comb into 100. I did the same thing. I did the other two variables both ways. I'm coming in here and I'm looking. And, you know, it kind of looks like these go down again like before. But side and up, I don't see what I saw before. So again, I'm going to pick one of them. I'm going to say, look, let's say side and up doesn't matter. And look at large, medium, and small. Large, medium, and small. There they are right there. Doesn't really look like they make a difference. I'm going to do the averages just to see. And again, sometimes looking at the boxes can be a little misleading because these down here are bringing the average down. And again, there's a lot of overlap. I don't think it matters, but just to be careful, I did a t-test. And again, this was where it was very easy to do the t-test because I just let the pivot table give me the numbers. So I looked at large and medium and 1.2 versus 2.1. There's not enough evidence to say that mass matters between large and medium. Okay, and then I said medium and small. Same thing, 1.4 versus 2.7, not enough evidence. Then I did large to small, and it did show significance, 2.4 to 2.2. There is a 3% chance that that happened randomly. Okay, so now I'm at a dilemma. There was a difference there, statistically speaking. Here's what I did in my experiment. I said, okay, number one, this is really weird. The beam equation, mass should not matter, but we were new to 3D printing. So was there something strange going on we didn't know? I'm not sure. It's not strong evidence, but something might be there. So what I said, okay, for this experiment, I'm going to combine large, medium, and small for a couple reasons. One, it makes things a whole lot easier. Two, I don't have strong evidence, but I am going to make a note and say we need to go back and explore this. But for me, trying to determine the modulus of elasticity, it's not enough of a difference for me to call it out. So I am going to go ahead and combine, say mass doesn't matter, and combine across those. And so I do that. And then I look at side and up. Again, this looks like a no-brainer. I go ahead and do tool number 2 and go ahead and do tool number 3 just to show. And there is a 58% chance that this happened randomly. Yeah. So for 100%, what did we learn? Let me run down to 100% real quick. We learned that orientation, there's not enough evidence to say it matters, a P of 0.59. And mass, there's not enough evidence to say that it matters, but it is odd. And up here, the orientation is a P of 0.003. So what that means, what can I expect for E? For 30%, I have to report it separately. So for the side, that's the average. That's the standard deviation of the x's, not the x bars. And for 100%, I can report 1. So you see how this plays out on our table. We found out that neither the mass nor the orientation matters, so I can combine all of these. Over here, orientation mattered, so I had to summarize them both separately. Okay, and then don't forget this last thing. Under what conditions do my conclusions hold true? So for us, we used one printer. So it's only for this printer this is what we can expect. Also, we only use one spool of material for each color. Well, how much batch to batch difference is there? Would it be different if we used a different spool of material? We don't know. And we only printed one beam. We did that so that we could get 4 readings of hanging the mass on because of the variability involved in that. If we were to do it again, we'd print multiple beams. But again, you see why it's important to come back to this step and say, okay, what do I really know? And lay it out. Okay, here's what I can say for sure. For this printer and this spool of material and these beams, here's the modulus, and the fill matters for 30%. That's what I know for sure. Can I expand that to more beams and more material? Not without some more testing. But again, that's okay. We learn in steps. If we had tested all that in one, we would have had a zillion beams that we had to test. It would have taken a lot longer. This way, we've learned some and we know the directions to step into. Okay, one last thing. This last question we haven't talked about. But now, for us, we know that fill matters. And there is a relationship between E and fill is numeric. So we can ask ourselves, what is that relationship? We can come down here and say, okay, what is the relationship? But we have to remember that these are separate. So we've got to look at 30, the relationship between 30 up and 100 and 30 side and 100. So what we could do is we could graph these on an XY graph. And this could start to lead us to understand the relationship, but we can't draw a line between these. I intentionally have no lines because since we only have 2 points, we have no clue what the relationship looks like between these two. That's where when you're going to have numeric variables and you want to come up with a relationship, you need at least 3 levels in your variable so that we have some kind of idea. Okay, does this fall in here somewhere, or is it down like this, or is it, we don't know. But this is what that third question is talking about, is when you know there's a relationship and your variable is numeric, then you can actually move to an XY graph and start to explore that relationship. Okay, that's it. I hope this example brings a lot of the things together for you and helps you, one, as you analyze the data for your design experiment, but also give you a foundation to go do this in the real world and to make good decisions. Thank you.